Imagine standing under a sky the color of twilight, but the air is thick with a metallic haze as the distant giant sun sets. The temperature begins to drop, not to a gentle cool, but to a searing 1,500 degrees. Then it begins. Droplets, not of water, but of glowing molten iron, condense in the upper atmosphere and fall like a hellish rain into the darkness below. This isn't a scene from science fiction. This is the real weather forecast on a planet 640 light-years away, and it reveals something profound about how the most extreme atmospheres in our universe truly work. This incredible world is named WASP 76b. It belongs to a class of exoplanets known as ultra-hot Jupiters, gas giants that orbit their stars at an impossibly close distance, completing a full year in less than 2 Earth days. This extreme proximity creates some of the most violent and bizarre conditions imaginable. For years, astronomers theorized about iron rain on this world based on initial data, but the idea seemed almost too fantastic to be true. Now, thanks to powerful instruments like the ESPRESSO spectrograph on the European Southern Observatory's Very Large Telescope, we have finally moved from theory to observation. In this episode, we will journey to this furnace world, explore the physics of its supersonic winds, and uncover the clever detective work that proved, once and for all, that it truly does rain iron in the cosmos. To understand the iron rain, we must first visit the dayside of WASP 76b. Because it's tidally locked, this hemisphere is trapped in a state of eternal day, perpetually roasted by its parent star. The temperatures here are staggering, soaring above 2,400 degrees Celsius. This is hotter than the melting point of most rocks and metals. On this side of the planet, iron doesn't exist as a solid. It's not even a liquid. It's a gas. The upper atmosphere is a searing furnace filled with vaporized iron floating alongside other elements. This intense heat is supplied by its star, which is significantly hotter and more massive than our Sun. Using the ESPRESSO instrument, astronomers could analyze the starlight filtering through the planet's atmosphere. They found the unmistakable chemical fingerprint, the absorption line, of iron atoms in a gaseous state, confirming that the air itself is laced with metal. A planet with one side hot enough to vaporize iron and the other permanently dark and cooler creates an enormous temperature difference, a gradient of over 1,000 degrees Celsius. In any atmosphere, a temperature gradient like this is a recipe for wind. But on WASP 76b, it generates winds of unimaginable ferocity. These are not mere gales, they are planet-circling supersonic jet streams. Scientists calculate that these winds, carrying the superheated iron vapor, race from the dayside to the nightside at speeds reaching 18,000 kilometers per hour. That's over 14 times the speed of sound. This isn't just a weather system, it's a planetary conveyor belt, a colossal atmospheric engine powered by the stark contrast between eternal day and eternal night. It constantly dredges up material from the hot side and violently transports it into the cold, dark abyss of the night side. As this river of metal gas screams across the terminator into the permanent darkness of the night side, its environment changes dramatically. The temperature plummets to a relatively cooler 1,500 degrees Celsius. Now, while that's still hot enough to melt lead, it is below the condensation point of iron. This is the critical moment. Just as water vapor in Earth's atmosphere cools to form clouds of liquid water droplets, the iron vapor on WASP 76b cools and condenses into clouds of tiny liquid iron droplets. Imagine it, vast, dark, heavy clouds, not of water, ice, or vapor, but of molten metal, swirling in the upper atmosphere of a gas giant's dark side. These clouds grow heavy, and eventually, the droplets of liquid iron become too massive for the atmospheric updrafts to support. Gravity takes over, and the molten iron begins to fall, precipitating out of the clouds and raining down into the planet's deeper, unseen layers. This entire process sounds logical, but how did scientists actually prove it? This is where the true elegance of the discovery lies. Using the VLT's ESPRESSO spectrograph, the research team observed the planet as it transited its star. They specifically looked at the light filtering through the atmosphere at the two different terminators, the boundary between day and night. When they analyzed the evening terminator, the edge where the superhot dayside is rotating out of view, they saw the strong, clear, spectral signature of iron vapor being carried by the winds. But then, when they looked at the morning terminator, the edge where the cooler nightside is rotating into view, the iron signature was gone. It had vanished completely from the upper atmosphere. This asymmetry was the smoking gun. The iron was present as a gas on one side, but absent on the other. The most compelling explanation is that the iron had condensed and rained out during its journey across the dark side. The story, however, has become even more complex and fascinating with further research. It's likely not just iron that's part of this extreme weather cycle. Data from other observatories, including the Hubble Space Telescope, suggests that other elements with similar condensation points are probably raining out as well. Think of metals like magnesium, nickel, chromium, and vanadium all participating in this process. But it gets weirder. Scientists also found the signature of sodium, but its presence was patchy and didn't follow the same pattern as the iron. This suggests an incredibly complex chemical gradient across the planet's atmosphere. It's not a simple, uniform system. Instead, different elements are condensing and raining out at different altitudes and longitudes, creating a cascade of varied metallic precipitations. WASP-76 isn't just a world of iron rain, it's a world with a dynamic, multi-layered weather system of different metals. So, what is the most profound takeaway from this world of metallic storms? The discovery on WASP-76b forces us to fundamentally rethink our basic concept of a planet. We tend to visualize planets as roughly symmetrical spheres, with weather that, while chaotic, operates under a globally similar set of rules. This planet shatters that notion. It is a world of two faces, a planet of radical, permanent asymmetry. One hemisphere is a stellar-blasted furnace, where the very ground is vaporized into the air. The other is a dark, cooler abyss, where that same material rains back down as molten metal. This isn't just a weather report, it's a blueprint for a completely different kind of planet. It tells us that for the countless, tidally locked worlds that likely populate our galaxy, their chemistry, their geology, and their very nature might be fundamentally split in two. Imagine a world where one side is an ocean of lava, and the other has continents built from exotic minerals that precipitated from the sky. This forces us to reconsider what planetary science even means in these contexts. WASP-76b is more than a scientific curiosity. It's a powerful lesson in cosmic diversity. It's a stark reminder that our own Earth's relatively gentle, symmetrical, and life-sustaining system is not the galactic default. It is, perhaps, a beautiful and precious exception. From vaporized rock to supersonic winds and falling liquid iron, WASP-76b serves as a natural laboratory for the most extreme physics in the cosmos. It challenges our assumptions and pushes the very boundaries of atmospheric science. With next-generation instruments like the James Webb Space Telescope now peering into these distant atmospheres with unprecedented clarity, we are standing at the dawn of a new era of exoplanet discovery. What other impossible weather systems and bizarre worlds are waiting to be found? If you're fascinated by the strange chemistry of alien worlds, you might enjoy our video on the theoretical diamond rain of Neptune and Uranus. Let us know in the comments what cosmic weather you find most mind-bending. For more journeys into the cosmos, be sure to subscribe and join our exploration.